Hello and welcome to the Data Engineering Podcast, the show about modern data management. You can go to www.dataengineeringpodcast.com to subscribe to the show, sign up for the newsletter, read the show notes, and get in touch. You can help support the show by checking out the Patreon page, which is linked from the site. And to help other people find the show, you can leave a review on iTunes or Google Play Music, tell your friends and coworkers, and share it on social media. Your host is Tobias Macey, and today I'm interviewing Eyal Gutkind about ScyllaDB. So, Eyal, could you please introduce yourself?
Sure. Thank you, Tobias, for having us. My name is Eyal Gutkind. I'm a solution architect at ScyllaDB, and basically we're working to help people put databases in a more efficient way, and that's what we do today.
And how did you first get involved in the area of data management?
So I started 6 years ago. I started coming up from the hardware plant. I was part of a company named Mellanox. We did high-performance networking, and one of the use cases are databases, high-performance databases. This is how I got involved. Later on, I moved through a company named DataStax, which provides Cassandra solutions today. And from there, I moved to ScyllaDB. So that's my journey.
It's interesting that you had the experience in DataStax before moving to the competing product of Scylla, or at least the supplemental product. So for anybody who isn't already familiar with it, can you explain a bit about what ScyllaDB is and what some of the advantages are that it has over some of the other products that are available?
Sure. So ScyllaDB, basically, it's the world's fastest column store database. Basically, we are delivering the same functionality as Apache Cassandra, but the speed that we are providing on top of it is basically the speed of I would say, the lightest and the most efficient key value store you can find in the market. But raw speed is not just nice, it's a benchmark. Scylla is actually bringing you an order of magnitude improvement to the performance. And we do it by basically redesigning the whole engine underneath the database and provide a very efficient usage of your either cloud-based, on-premise, or any type of other infrastructure you use to make sure that basically the processes of using transactions and backend processes are made in the most efficient way. It's the main core functionality that Scylla brings into the market. For the more higher level, basically you can think of us as the next generation Cassandra solution out there. This is how we will be basically addressing ourselves.
And what was the initial problem that was being faced when ScyllaDB was first created?
Sure. So I'll go to the roots. ScyllaDB started as a programming framework that's called C Star. Basically, the C Star framework, it's a C++ framework. It's a shared nothing architecture in a very efficient way that takes every process and attach it to a core inside your system, making sure that any process you have in your application basically is able to use system in an efficient way without getting clogged on CPUs or latencies on IOs and other good stuff. When we were looking where we can apply that type of framework, we basically looked at databases, and one of them was Cassandra. Applying C Star to Cassandra was fairly a straightforward process from our perspective, and this is how we found out that we can actually provide sometimes a tenfold performance over current implementations of Cassandra. More than that, the simplicity of usage is another aspect that when you're using a database, it's something that is almost, I would say, sometimes impeding the ability to scale. Using a simple way to scale a solution without a lot of tuning is the other aspect of it. And looking at Scylla, basically you can forget about all type of JVM tuning that in many cases you need to do in a Java-based application. Those tuning are not there anymore. We are able to provide a very efficient IO scheduling to make sure that we utilize your media as well as the CPUs in a more efficient way.
So it's interesting that you ended up building a database from an even lower level of the underlying framework as a way to test out that framework, and then ended up moving forward with the database project. So one of the things that first attracted me to ScyllaDB is the fact that it has that same capability and promise of Cassandra without the necessity of having to run and manage the JVM, because if you don't do that full time and make that your life, then it can be difficult to really understand what it's actually doing at all times and how to make sure that you can get proper reliability out of it. So on the note of reliability, particularly given the fact that Scylla is still a somewhat recent entree to the database market, I'm wondering, what are some of the mechanisms or testing approaches that you use to make sure that the underlying engine is sufficiently reliable and accurate for storing and managing people's data so that they can be confident that they can use it in a production context?
Sure. It's going to be a little bit cocky initially, but I'll go into the details later on. First of all, is our customers, the guys who are actually using today's Scylla in their implementations. We never heard a problem of stability. Yes, sometimes we are lacking a fixture here and there that they're looking for, another management capability they would like to have, but we have never heard about stability issues. And also, even what's called graceful failures are something that we are able to provide them. And that's the first part of it. The second one is there are, during the process of development, we have our own QA team who runs different longevity tests on Scylla and a constant benchmarking that is running, whether it's by our team, the solution architects, to make sure that we are providing the customers with the right solution, and other capabilities in terms of benchmarking that is always being updated from our perspective. We just published a week ago a benchmark of processing Scylla on Oracle Cloud Bare Metal services. And, again and again, we are testing the solution on a constant level to make sure that we don't crash. But I think the best testimonial we have is our customers.
And so what are some of the technical and architectural design choices that have been made to enable you to ensure that faster performance and that reliable uptime without resorting to the JVM while maintaining compatibility with Cassandra?
Sure. So for the performance side, there are, I would say, three aspects to it. First one that I mentioned is basically the share nothing architecture, and make sure that every core by itself has its own capabilities. And the second one is our memory management that we have in Scylla. So we don't, basically our cache and code, there is nothing like that at Scylla. It's only one cache memory. So we are more efficient in usage of that memory. Second one is we don't have what's called phantom rows. So we don't fetch a prescribed block of information from the media. We fetch the information you need, the information that is actually required by the query, to make sure that we are very, very efficient in the usage of this extremely pricey resource. That's the first one. That's another technical part. Another item is our networking stack, it's more efficient as well. So all these three items provide us the actual ability to provide that specific performance. And in addition to that, if you think about the JVM processes, we do not need that memory management or garbage collection that you have in a JVM or in Java-based application. Basically, we are able to provide a very robust, all server included capability. If you look on the different applications, how they actually tell you which part of the JVM setting to put, for example, limit your memory, limit your CPUs, use which how to use cache pages, etc. All that type of needs are not there anymore. So it's a more well-tuned solution. I want to add something to that. When you start Scylla, basically the first thing we do is we evaluate the system that we are working on. So the actual, I would call it quote unquote physical, whether it's cloud or physical server, we boot up Scylla and we learn what are the capabilities inside that machine. So Scylla will basically auto-tune itself to the host that you're running with, and making sure that we don't oversubscribe, don't overcommit, don't underutilize this, again, the pricey resource that you have paid for. Whether it's going to be on the I/O side, whether it's an SSD or a spindle disk, the amount of memory, the amount of cores that you have in the machine, all those parameters will be taken into Scylla and basically auto-tune itself to that specific instance that you have provided us to put Scylla on. All those type of metrics provide you basically with the ability to be very, very accurate in terms of capacity and capabilities, and prevent at the end of the day overcommitting, oversubscribing, and then the end of it is basically either a crash or a very poor performance from your side as a user.
And are some of those auto-tuning capabilities a byproduct of the fact that it's using the C* framework, or are some of those routines something that's specific to the implementation of Scylla itself?
Some yes and some no. For example, we are, as I said before, we are actually tuning or learning what the, let's say, your SSD capabilities are. We will learn exactly what is the most efficient point in terms of both latency and throughput of your SSD. Taking it back to Scylla into the C* framework, we know exactly how many requests of I/O we can actually put concurrently into that specific SSD. If we provide more, if we actually put more concurrency to that specific use case, what will happen is the latency will just jump high, and the performance and the capabilities from you as a user are actually degraded. So using that optimum point, it's something that you have to learn the system you're working with. It's impossible for any other framework to actually use that type of information. We take that information, we'll learn exactly what the I/O capabilities are, and push it down to C*.
And on more of the tuning piece in terms of the deployment environment, I know that I was recently working on doing a test deployment of Scylla, and it was recommending the XFS file system for being able to get appropriate utilization out of the underlying hard disk. So I'm wondering if XFS itself has been deemed to be the best file system, or if there are any other considerations that would factor into choosing one or another file system, or any other specific configuration parameters of the OS that Scylla is running on.
So XFS, I think, and it's not just me saying it, or Scylla saying it, others are saying it, it's the most efficient and most performant file system out there. Having said that, we do understand that there are customers who, for example, want to stick with ext4. It's not something that we don't see it. We do plan to support ext4. If customers are willing to understand that, they might, sometimes they will willing to pay for performance for the usability. So that's the idea. We still recommend XFS as the most efficient file system from our perspective.
Yeah, I can back that up experientially, having used XFS for a particular use case where I needed to write out and read back a lot of small files as rapidly as possible for something unrelated to databases, but specifically for small image formats. And in my experiment, I was able to get a drastic speed up by switching to XFS from ext4. So it's understandable why you would recommend that as the underlying storage for the actual database system itself.
Yeah, that's the main reason, because we hate additional layers of either inefficiency or latency that actually impede our ability to provide value to customers.
So Scylla aims to be API compatible with the Apache Cassandra database. So I'm wondering, what are some of the challenges that are introduced as a result of needing to maintain that compatibility? And are there any plans or even current implementations of additional or alternative feature sets from the Apache Cassandra project?
So we definitely follow what's going on the Apache community, and we encourage everybody on the Apache community to come and follow us as well. We do want those community to help each other. Having said that, on the API part, it is sometimes a challenge. I must admit, it's not straightforward. But providing a compatible API from our perspective is actually helping the Cassandra customers to understand the value that they can get from Scylla, or the users themselves. It's a challenge to follow up sometimes on a protocol. For example, we do want to support v4 of CQL, and this is something that we are planning and working on to bring it to the market as well. And we do support, for example, the legacy Thrift protocol. So we do have other protocols that we are able to implement on top of Scylla and provide that compatibility. It's not fun to play. I must admit, it's not fun to play always the game of catch up. But we also think that in order to make sure that the usability of Scylla is easy, this is a price we're willing to pay.
And I know from speaking to people who have done similar approaches where they need to replicate the functionality of another system that oftentimes you not only have to replicate the intended use of the APIs and the intended output, but also the bugs that are implemented in different versions so that you can have a truly drop-in replacement without any surprises. So I'm wondering what kind of experiences you've had on that front.
We did have some of those, and I'm laughing because it's something that recently happened. And, it does happen. There are sometimes bugs that exist in a certain API that you replicate it and you find out, people say, by the way, we fix some of those issues, and then people say, hey, it doesn't behave the same. So we have to replicate the bug as well. It does happen. But looking forward, definitely is something that we do want to make sure that our APIs are compatible. But we do think that there are other APIs in the market that we can definitely help and create value in. And there are tons of them out there, whether there are caching systems, other databases that are very, very, I wouldn't say dominant, but definitely something that they are in the market. And we think that using Scylla as the underlying asset for them is something that can be useful.
And I know that there are a number of plugins or additional layers that can be run on top of Apache, such as the OpenTSDB, and I believe it's TitanDB that was recently acquired to operate as a graph database layer on top of Cassandra. So I'm wondering, given the fact that Scylla doesn't use the JVM, whether it's possible to use those additional plugins or additional layers on Scylla the same way as they are used with the original Apache Cassandra project.
It is possible. So for example, you mentioned Titan. Basically, Titan used Thrift protocol. One of the reasons we provided Thrift protocol at Scylla is to be able to support Titan. So that's something that you can do today. Use Titan over Scylla. It works. I think it was actually presented by Jason Plurat from IBM on our Scylla summit in September. Other ones that you would find very dominant and very, I would say, pervasive is the Kairos DB one. It's something that you can do that, as well as the Apache Spark. So all those protocols are supported and are functional on top of Scylla.
And so do those just run in a JVM process and they just use the standard Cassandra APIs to send data back and forth just as with any other client library?
Correct. For example, the Spark one will use but use the regular CQL commands to move data back and forth. Same thing with Kairos, as I said. For Titan, it's going to be the Thrift protocol. So all of them, it's going to be, yes, it typically is an adjacent cluster that just put transactions back and forth to Scylla.
So as new APIs are added to the upstream project, what's the lag that you typically have between when it's released upstream and when you're able to replicate it?
It depends. It sounds funny. Basically, we make sure that if there is something new and we find out that it is something that most users look for it, but will be faster to implement, even with our current solution, without going through major revisions. It's something that we always look to. It's not every API that we think that is available on the Apache Cassandra is something that is highly usable. We try to make sure that the APIs that we provide actually help users to use Scylla/Cassandra in a more parallel way, let's call it.
And if you already have an existing Cassandra cluster and you're interested in moving all or at least a portion of your data to Scylla, is it possible for Scylla to join that existing cluster, and do a live data migration via replication so that you can have a zero downtime swap so that you can bring Scylla into production without ever having to take your cluster down?
So the short answer is yes, and the longer answer is no. So Scylla has a different gossip protocol. So you cannot join a Scylla node to an existing Cassandra cluster. They just would not talk to each other. That's not going to happen. There are two ways you can do that type of migration. One option is to stand up a parallel Scylla cluster next to your Cassandra one and do a dual write and dual reads. And once you feel confident enough that those transactions are not differing in any way or shape, you can shut down your Cassandra cluster and use only the Scylla one. And that's the most straightforward way to, I would say. And the more enterprisey way, we do have a solution to help migration from Cassandra to Scylla. This is part of our enterprise product. And this is something that we are able to provide you. We basically hook up on your Cassandra cluster and replicate the transactions into the Scylla one. That's a possibility. Most of our customers choose the first option as of today. That's something that it's very popular. Basically, they don't need our help at that point. Stand up a Scylla cluster, send up a Cassandra cluster. We do have compatibility on the SS table format. So if you're using a 2.1.x SS table format, you can copy the SS tables to the Scylla cluster. Make sure that you have the right token ranges in every node. Fire up the cluster and let it catch up with your Cassandra cluster. At the end of the catch-up process, basically you can shut down the Cassandra one.
And given the fact that you are able to get such higher throughput and performance on a Scylla cluster from a corresponding Cassandra one, I imagine that there are times where if you're not running a substantially large Cassandra cluster, that it might make sense from a cost perspective to actually run Scylla in a single node environment, but at the same time you'd be trading off the redundancy and high availability guarantees that you get by running a cluster. So I'm wondering if you've had people run into that kind of situation, or if it just makes sense for them to simply run it on smaller hardware and still cluster it together.
I would argue that if you're trying to find a way to, whether it's Cassandra or Scylla, run it on a single node for a production environment, I think you're doing a disservice to both technologies. That I would say it's an anti-pattern for the actual implementation. The idea of Cassandra/Scylla is high availability and basically resiliency. And you would need a cluster. You can definitely shrink the cluster. So we have seen clusters of 100, 200 nodes of Cassandra shrinking down to 30 and 50 and 60 nodes. So then the cost saving is significant and imminent to the operation team. It's not just the cost of the hardware or the cost of the cloud services. It's also the cost of managing it. Managing a 200 node cluster or a 100 node cluster requires a lot of resources, both human as well as systems, and shrinking down by 3-4 folds the size of the cluster basically release those resources to do more efficient and more adequate processes for your business, and not just help them look on metrics that come from 100 nodes. That's something that we have seen, and we are seeing it every day that we work. Those are the main gains that we are able to see in terms of shrinking. Going down from 3 to 1, I wouldn't say it's not possible. It's possible. Most of functional tests that, for example, I do will be running on my virtual box on my laptop, but definitely I wouldn't recommend any production system to go that route.
Yeah, I would definitely agree on that front. Being somebody who manages infrastructure for my day job, anytime I see a potential for a single point of failure, it just makes me cringe. So I definitely appreciate systems like Scylla and Cassandra that are easily clustered for high availability and reliability, because it makes me sleep easier at night knowing that even if I do have a catastrophic node failure, I can still just continue sleeping because everything will stay running until the morning.
And that's the main use. And not just that, think about multi-data center replication that comes automatically in this architecture. It's one of I think the key values for using such a multi-master architecture that you have. And we see those as the most, we'll say, dominant use cases.
Yeah, being able to replicate across data centers and across regions is definitely highly valuable for latency purposes if you're serving a global audience, because of the fact that you can locate the data closer to the consumer as opposed to a more traditional database like MySQL or Postgres, where it becomes fairly difficult to handle sharding or replication just because of the nature of the database itself and the way that it's structured. When you do need to go multi-region, it's typically quite a headache, or it even potentially necessitates a complete architectural shift in the way that you manage your data.
That's exactly the cases. We see people ship when they need to scale, and mostly in the, I would call, web front applications, when they find out that, okay, that's it, we scale to the maximum we can get from our current solution. The first thing they find out is basically the Scylla architecture. And that's, I would say, the number one transformation phase we have seen.
And you've mentioned a couple of times some of the services that you provide as a company around Scylla, the database. So I'm wondering what prompted the decision to form a company around the database once it was created, and also some of the challenges that you faced as a company that is trying to make money off of an open source database, particularly in light of recent failures such as RethinkDB.
So I think we all read the RethinkDB blog, an excellent blog, by the way, in my opinion. So it is a challenging environment, don't get me wrong. And the value that we bring in is basically our knowledge of both the database itself, how it is operating, as well as the additional capabilities. We do have an enterprise version that we have additional enterprise features that people are looking for example, security, and you can think of any other type of enterprise grade capabilities you need. So that's an enterprise version. And in terms of information that we provide to the users, we do have our own professional services to help users that need those capabilities to, speed up their ramp up or don't have the technical depth to maintain a cluster like that. We definitely come in and help them. Those are the services that we provide for a fee. And we see more and more customers looking for those services. So both the support, the enterprise features, as well as the services on top of them is something that people are using us for. We do also provide training. So if you are a novice, or even if you are a proficient user of Scylla, we are more than happy to come in and provide you with training, whether it's going to be if you just need a jump start, so it's typically a single day, or you need a deep dive to Scylla, to the architecture and the way it's operate. That's a 3-day class that we provide. So this is how we make money. In terms of competition, as always, I think as any other open source, we typically compete with ourselves. The open source competes with the enterprise. But that's, I think, the nature of this business. If we're going to be successful, I believe that we do. I think we have a winning product. I do think we have an advantage over current implementations that are out there in the market. I do hope that customers are able to see those values and are willing to pay for them. And that's the idea at the end of the day.
So going back to the C-Star framework, you were saying that Scylla was essentially initially created as a proof of concept for the C-Star framework. So I'm wondering if there's any intent to maybe build out different types of database systems with C-Star or other kinds of applications. And also, what are some other uses of C-Star from other projects that you're aware of that you have found particularly interesting?
Sure. So there is one. C-Star is an open source. So we have seen somebody took C-Star and created a Redis database on top of it. So it's called PEDIS, PEDIS. So we encourage those by all means. We think it's a value that C-Star can bring to the market. I can tell you that right now our hands are full, both with customers and features that we want to bring into Scylla. But if you look on the presentation by Avi Kiviti, Scylla CTO, you'll see that we have multiple ideas in the analytics space and in the search space, in terms of storage efficiencies, and many more goodies that we want to bring into the market. So I think that we really have a handful tasks to make, and I don't think there is enough time in the day to complete them all. So we do look outside our box and understand exactly what the applications are going and what are the use cases, and those are the items that we're looking for. I'll give an example. We see a lot of people using Scylla, for example, for their IoT project or sensor data. It's something that we definitely want to look into.
Yeah, and that brings up another interesting point is when you are working on providing compatibility with an existing system so that you can be a drop-in replacement, wondering what you see as the areas of innovation, given that most of it can't be done externally in terms of the interfaces that you provide to other people using the system. So it means that a lot of the innovation needs to happen internally or under the covers. So I'm wondering what your experiences are with that.
I will not disclose probably most of the information on this podcast as a public one, but definitely it's something that we take the feedback in. We try to find the solutions and, as you said, to bring the innovation to the customer under the umbrella of CQL and the actual APIs that we have today. However, we're not going to be shy if there is a need to provide some type of a specific capability to a specific use case. We think it's something that we will be able to provide customers in addition to the implementation that they are familiar with and the drop replacement capabilities.
Are there any other subjects that you think we should cover before we start to close out the show?
Use Scylla. I do think that Scylla can provide value to customers who are either struggling with their current Cassandra implementation or they want to use it as on a greenfield type of implementation. I think we are able to be very efficient, very easy to deploy. It's something that sometimes people don't discount the time to working. So if you are you want to make sure that database installation is not your business, but something else is your business. For example, whether it's a customer retention program, IoT, time series. Implementing Scylla is very simple. It's a simple one script that makes all the tuning for you and bring you a working database into your front door. That's the idea here.
And that reminds me of one thing that we didn't cover yet is, given that it is a more low-level language implementation, I imagine that somewhat restricts the platforms that it can run on. So the JVM, you could potentially run it on Windows or OS X and Linux, but I'm assuming that the platform, the deployment targets for Scylla are a little bit more constrained. Is that correct?
Well, yes and no. I have not yet haven't seen an implementation of Cassandra or Scylla on other systems than Linux, and I think that most implementations of the NoSQL space are on a Linux-based machine. Yes, there are implementations that use both OS X and Windows, but I think there is a vast market that is using the Linux space. We are supporting both, Red Hat, CentOS, Ubuntu, Debian platforms. So I think it covers most of the market. That I don't think that should be the preventing item from actually implementing a Scylla.
Yeah, I can agree on that front. I don't think I would want to run it on Windows or OS X, but I suppose if somebody did want to, they could. I just wouldn't be the one supporting it for them.
Yeah, it's. I'm not bashing those operating system. I am an avid OS X user. I'm not shy of it. But I don't think that's the right platform for such a database. As we said before, it's for a clustered system. That's where we're targeting Scylla.
For anybody who wants to keep in touch with you and Scylla, I'll ask you for your preferred contact information, and I'll add that to the show notes in case anybody wants to get in touch and dig a bit deeper into Scylla.
Sure. So a couple of things. If you want to join Scylla or you want to work with Scylla, I highly recommend we have our website, which is at www.ScyllaDB.com. We have our public Slack channel. We have a public mailing list. Please jump on it, use it. We are constantly listening and we're constantly answering. And I can tell you answering is darn fast these days. So we have people really jumping on to help customers board Scylla.
Well, I appreciate your time this evening. It was a pleasure to get to learn a bit more about Scylla and how it came to be and some of the different ways that I can leverage it. And I'm sure a number of other people will be giving it another look. So thank you for your time, and I hope you enjoy the rest of your evening.
Thank you very much, Tobias. Appreciate it.